If I don't need any more gasoline, what would happen? If I don't need any more electricity or gas, what would happen? If I don't need any more medicines from the pharmaceutical industry, what would happen? What would happen?
Roger, copy mission.
We live in an age of astonishing advances.
Sending at about 0.75 meters per second.
Engineers can land a car-sized rover on Mars.
Touchdown confirmed. Proceed on Mars.
Physicists probe the essence of all matter, while we communicate wirelessly on a vast worldwide network. But underlying all of these modern wonders is something deep and mysteriously powerful. It's been called the language of the universe, and perhaps it's civilization's greatest achievement. Its name? Mathematics. But where does math come from? And why in science does it work so well?
Albert Einstein wondered, how is it possible that mathematics does so well in explaining the universe as we see it?
Is mathematics even human?
There doesn't really seem to be an upper limit to the numerical abilities of animals.
And is it the key to the cosmos?
Anti-gravity exists. The ability for everyone to be a genius exists. Aliens exist. And much more efficient ways of producing energy exist.
2, 1, 0.
Yeah. Oh, that was really cool, actually, Garrett. That was actually very, very cool. All right, so.
They said we all have bodies, but we don't just have physical bodies, we have light bodies. And just as we feed our physical bodies, they said, we have to feed our light bodies so that they will be nurtured and grow in the same way. They have to be as fulfilled as the physical body. And they call the light body the car. But it's interesting because scientists in recent times have actually called this material the light of life, because it resonates with DNA on the same frequencies. It's a light wave.
Our DNA is in fact a vibrating light wave, an extension of our light bodies, and it must be kept and nurtured just as we do our physical bodies. To those suffering from illness and have only been offered pharmaceutical drugs to aid in your recovery, or to those who simply wish to learn more of the secrets of alchemy and our relationship to the divine frequency, observed in sacred geometry, cymatics, and magnetism, the very source that drives the cogs and rhythms of the universe. I implore you to look within yourselves to the truths presented here, and join us on the scientific rediscovery of a lifetime.
Think about these maxils. Somehow this machine creates north and south polarized maxils inside the magnet. You can add these pixels up to basically make images that can create forces. If you couple one image with a complementary image, you can then create incredible three-dimensional behaviors.
Human beings have always looked at nature and searched for patterns. Eons ago, we gazed at the stars and discovered patterns we call constellations, even coming to believe they might control our destiny. We watched the days turn to night and back to day, and seasons as they come and go, and called that pattern time. We see symmetrical patterns in the human body and the tiger's stripes, and build those patterns into what we create, from art to our cities.
In medieval times, alchemists tried to achieve the seemingly impossible. They wanted to transform lowly lead into gleaming gold. History portrays these people as aged eccentrics, but if only they'd known that their dreams were actually achievable. Indeed, today we can manufacture gold on Earth, thanks to modern inventions that those medieval alchemists missed by a few centuries. But to understand how this precious metal became embedded in our planet to start with, we have to gaze upwards, at the stars. Gold is extraterrestrial. Instead of arising from the planet's rocky crust, it was actually cooked up in space and is present on Earth because of cataclysmic stellar explosions called supernovae. Stars are mostly made up of hydrogen, the simplest and lightest element. The enormous gravitational pressure of so much material compresses and triggers nuclear fusion in the star's core. This process releases energy from the hydrogen, making the star shine. Over many millions of years, fusion transforms hydrogen into heavier elements, helium, carbon, and oxygen, burning subsequent elements faster and faster to reach iron and nickel. However, at that point, nuclear fusion no longer releases enough energy, and the pressure from the core peters out. The outer layers collapse into the center, and bouncing back from this sudden injection of energy, the star explodes, forming a supernova. The extreme pressure of a collapsing star is so high that subatomic protons and electrons are forced together in the core, forming neutrons. Neutrons have no repelling electric charge, so they're easily captured by the iron group elements. Multiple neutron captures enable the formation of heavier elements that a star under normal circumstances can't form, from silver to gold, past lead, and on to uranium. In extreme contrast to the million-year transformation of hydrogen to helium, the creation of the heaviest elements in a supernova takes place in only seconds. But what becomes of the gold after the explosion? The expanding supernova shockwave propels its elemental debris through the interstellar medium, triggering a swirling dance of gas and dust that condenses into new stars and planets. Earth's gold was likely delivered this way before being kneaded into veins by geothermal activity. Billions of years later, we now extract this precious product by mining it, an expensive process that's compounded by gold's rarity. In fact, all of the gold that we've mined in history could be piled into just 3 Olympic-sized swimming pools, although this represents a lot of mass because gold is about 20 times denser than water.
But what do patterns tell us? Why should the spiral shape of the Nautilus shell be so similar to the spiral of a galaxy? Or the spiral found in a sliced open head of cabbage? When scientists seek to understand the patterns of our world, they often turn to a powerful tool, mathematics. They quantify their observations and use mathematical techniques to examine them, hoping to discover the underlying causes of nature's rhythms and regularities. And it's worked, revealing the secrets behind the elliptical orbits of the planets to the electromagnetic waves that connect our cell phones. Mathematics has even guided the way, leading us right down to the subatomic building blocks of matter. Which raises the question, why does it work at all?
A metaphysical and scientific value, the secrets of which have been lost but were destined to one day return. This has happened with the rediscovered science of monatomic high-spin metallurgy, the ability to transmute noble metallic elements into a single atom, superconductive, anti-gravitational state. During the course of David Hudson's research concerning orbitally rearranged monatomic elements in the latter 1990s, the medical fraternity began to take a keen interest in the potential use of Ormes for cancer treatment. Journals such as Platinum Metals Review and Scientific American had reported how monatomic platinum group metals will resonate with deformed body cells, causing the DNA to relax and become corrected.
What's so impressive and so dramatic is that a single mathematical law would allow you to move throughout the universe.
Was the same force that brought cannonballs back to Earth. It was the force behind Galileo's law of falling bodies. and it even held the planets in their orbits. He called the force gravity and described it precisely in a surprisingly simple equation that explains how two masses attract each other, whether here on Earth or in the heavens above. Is there an inherent mathematical nature to reality? Or is mathematics all in our heads?
Of other phenomena which have, at least on the face of it, nothing to do with circles or anything. In particular, it appears in probability theory quite a bit. Suppose I take this needle, so that the length of the needle is equal to the distance between two lines on this piece of paper. And suppose I drop this needle now on the paper.
Sometimes when you drop the needle, it will cut a line, and sometimes it drops between the lines. It turns out the probability that the needle lands so it cuts a line is exactly 2 over pi, or about 64%.
Now, what that means is that in principle, I could drop this needle millions of times. I could count the times when it crosses a line and when it doesn't cross a line, and I could actually even calculate pi. Even though there are no circles here, no diameters of a circle, nothing like that. It's really amazing.
Researchers from the University of Michigan have created an elastic gold polymer that can stretch and still have metallic properties, like being able to transport electrons. Using gold nanoparticles and elastic polyurethane, they have made a material that doesn't require spring or coiled-shaped wires to maintain conductivity. The ability of the metal to maintain structure and conductivity when it's stretched could make it a valuable technology. It might be used in the future as flexible electrode implants to treat brain or heart conditions in humans. Getting implants that fit to the moving human body is an important step for biocompatible electronics. The nanoparticles used in the conductors were specially designed in the lab to have a thin shell surface.
Well, it actually goes by several different names. People who are familiar with it, monoatomic gold seems to be the title that I found on my own as I was researching it. The element gold, of course, goes by AU on the periodic table.
If I don't need any more gasoline, what would happen? If I don't need any more electricity or gas, what would happen? If I don't need any more medicines from the pharmaceutical industry, what would happen? What would happen?